We know what a chemical equation is, and we've learned how to balance it. Now we're ready to learn about stoichiometry. And this is an ultra fancy word that often makes people think it's difficult, but it really is just the study or the calculation of the relationships between the different molecules in a reaction. This is the actual definition that Wikipedia gives. Stoichiometry is the calculation of quantitative or measurable relationships of the reactants and the products. And you're going to see in chemistry sometimes people use the word reagents. For most of really our purposes, you can use the word reagents and reactants interchangeably. They're both the reactants in a reaction. The reagents are sometimes for special types of reactions where you want to throw a reagent in and see if something happens and see if your belief about that substance is true or things like that. But for our purposes, a reagent and a reactant is the same thing. So it's a relationship of the reactants and products in a balanced chemical equation. So if we're given an unbalanced one, we know how to get to the balanced point. Balanced chemical equation. So let's do some stoichiometry. And what I'm going to do is I'm going to start, just so we get practice balancing equations, I'm always going to start with an unbalanced equation. So let's say we have iron 3 oxide. So it's iron. You have 2 iron atoms with 3 oxygen atoms, plus aluminum, Al, and it yields Al2O3 plus iron. So remember, when we're doing stoichiometry, first of all, we want to do with balanced equations. A lot of stoichiometry problems, they'll give you a balanced equation, but I think it's good practice to actually balance the equations ourselves. So let's try to balance this one. We have 2 iron atoms here, right, in this iron 3 oxide. How many iron atoms do we have on the right-hand side? We only have 1, so let's multiply this. Let's multiply this by 2 right here. All right. Oxygen, we have 3 on this side. We have 3 oxygens on that side. That looks good. Aluminum, on the left-hand side, we only have 1 aluminum atom. On the right-hand side, we have 2 aluminum atoms. So we have to put a 2 here. And we have balanced this equation. So now we're ready to do some stoichiometry. So stoichiometry is essentially, look, if I give you, I mean, and then it's, there's not just one type of stoichiometry problem, but they're all along the lines of, hey, if I give you X grams of this, how many grams of aluminum do I need to make this reaction happen? Or if I give you, Y grams of this molecule and Z grams of this molecule, which one's going to run out first? That's all stoichiometry. We'll actually do those exact 2 types of problems in this video. So let's say that we were given, 85 grams. We were given 85 grams of the iron 3 oxide. So we're given 85 grams. So my question to you is, how many grams of aluminum do we need? How many grams of aluminum? Well, you look at the equation, you immediately see the mole ratio. So for every mole of this, so for every 1 atom we use of iron 3 oxide, for every 1 of that, we need 2 aluminums, right? So what we need to do is figure out how many moles of this molecule there are in 85 grams. And then we need to have twice as many moles of aluminum, right? Because for every mole of the iron 3 oxide, we have 2 moles of aluminum. And we're just looking at the coefficients. We're just looking at the numbers. 1 molecule of iron 3 oxide combines with 2 molecules of aluminum to make this reaction happen. So let's first figure out how many moles 85 grams are. So what's the atomic mass, or the mass number of this entire molecule? Let me do it down here. So we have 2 irons and 3 oxygens. Right? So let me go down and figure out the atomic masses of iron and oxygen. So iron is right here, 55.85. I don't know, I think it's fair enough to round to 56. Let's say we're dealing with the version of iron, the isotope of iron that has 30 neutrons, so it has a mass number of 56. So iron has 56 atomic mass number, and then oxygen we already know is 16. So iron was 56. So so this mass is going to be 2 times 56 plus 3 times 16. We can do that in our heads, but this isn't a math video, so I'll get the calculator out. So let's see. 2 times 56. No, sorry. 2 times 56 plus 3 times 16 is equal to 160. Is that right? That's 48 plus 112, right, 160. So one molecule of iron 3 oxide is going to be 160 atomic mass units. So 1 mole, or 6.02 times 10 to the 23 molecules of iron oxide, one of those pop-ups, iron 3 oxide, is going to have a mass of 160 grams. So in our reaction, we said we're starting off with 85 grams of iron oxide. How many moles is that? Well, 85 grams of iron 3 oxide is equal to 85 over 160 moles. So that's equal to 85 divided by 160 equals 0.53125 equals 0.53 moles. So everything we've done so far in this green and light blue, we figured out how many moles 85 grams of iron 3 oxide is. And we said for every mole, we figured out it's 0.53 moles, because a full mole would have been 160 grams, but we only have 85. So it's 0.53 moles. And we know from this balanced equation that for every mole of iron 3 oxide we need to have 2 moles of aluminum. So if we have 0.53 moles of the iron molecule, iron 3 oxide, then we're going to need twice as many aluminum. So we're going to need 1.06 moles of aluminum, right? I just took 0.53 times 2, right? Because the ratio is 1 to 2. For every molecule of this, we need 2 molecules of that. So for every mole of this, we need 2 moles of this. If we have 0.53 moles, you multiply by that by 2, and you have 1.06 moles of aluminum. All right, so we just have to figure out how many grams is a mole of aluminum, and then multiply that times 1.06, and we're done. So aluminum, or aluminium, as some of our friends across the pond might say. Aluminium, actually I enjoy that more. Aluminium has an atomic, the atomic weight, or the weighted average is 26.98. But let's just say the aluminium that we're dealing with has a mass of 27 atomic mass units. Right? So one aluminium is 27 atomic mass units. So 1 mole of aluminium is going to be 27 grams, or 6.02 times 10 to the 23 aluminium atoms is going to be 27 grams. So if we need 1.06 moles, how many is that going to be? So 1.06 moles of aluminium is equal to 1.06 times 27 grams. And what is that? What is that? 1.06 times 27 equals 28.62. So we need 28.62 grams of aluminium. I won't write the whole thing there. In order to essentially use up our 85 grams of the iron 3 oxide. And if we had more than that, what was the number? More than 28.62 grams of aluminium, then there'll be left over after this reaction happens, assuming we keep mixing it nice and, and the whole reaction happens all the way. And we'll talk more about that in the future. If we have and in that situation where we have more than 28.63 grams of aluminium, then this molecule will be the limiting reagent, because we had more than enough of this, so this is what's going to limit the amount of this process from happening. If we have less than 28.63 grams of, I'll start saying aluminum, then the aluminum will be the limiting reagent, because then we wouldn't be able to use all the 85 grams of our iron molecule, or our iron 3 oxide molecule. Anyway, I don't want to confuse you in the end with that limiting reagents. In the next video, we'll do a whole problem devoted to limiting reagents.